Good morning, afternoon, or evening, wherever you may happen to be, and whether you're watching live or archived. Welcome to another Nautel Transmission Talk Tuesday webinar series. We've been having a lot of fun hitting a bunch of different things, and today we're going to talk about site monitoring. This is one of those cool things. You've heard me talk in previous sessions about how it's just such a great time with all this social distancing to get out to the transmitter site where social distancing is just part of the game. The challenge is we're getting more and more folks geared up to do work from home or remote broadcasting. There's less time to go to the transmitter site. So how do we keep an eye on things that are going on out there? We've got a couple of great guests today, both great good friends and great engineers in their own rights. I've got Jeremy Priest, Senior Manager of Engineering for KLove Air One. Jeremy, thanks very much and welcome.
Good morning, afternoon, evening.
There you go, it all applies. And we've got from the scenic metropolis at Chelsea, Alabama, Josh Bone from Bone Broadcast Services and Max Connect Wireless. Josh, thanks for coming.
Absolutely, thanks for having me on. It's a rainy day in Chelsea.
That sounds like it should be a country song. All right, so we'll get started. One of you guys has got speakers playing. I can hear myself echoing, so just give you a heads up on that one. We're going to have a few housekeeping things to talk to at the first. So you've got a control panel on your webinar screen. If you've been to one of our webinars before, then you've seen this and it's not news. But if you're new to this, there is a question window. And if you enter questions in there, I'll see them and we'll address them as they show up. There's also a little hand waving icon. There you go, my new word. But the hand waving icon, by all means, if you click on that, it'll show me the raised hand and periodically I'll address those. We can unmute you and we'll do voice communications. So if you'd rather type, that's great. But if you're one to step up to the microphone, then certainly raise your hand and we'll have some fun. What we want to do is kind of look at the ways, and so we've got a good blend here. Jeremy, you guys arguably maintain one of the largest NOCs for broadcast around, not necessarily but it's up there. And
for
so
radio, at least, yes.
Yeah, and you've really evolved your system a lot over the years, so we might pick your brain a bit there. And Josh, you guys have, I mean, in your infinite spare time, you're a station owner as well as an engineer, yeah?
Yeah, absolutely. So
Decatur, yes?
Decatur, Alabama, WIEZ, AM and FM. So yeah, it keeps us busy.
Well, like I said, infinite spare time because we've all got plenty of that.
That's right.
So our agenda is pretty simple. We're going to have just a brief discussion with these two gentlemen, and then we're going to hit a few points and open it up for questions, same as we always do. Here are where I see things going, but certainly if anybody out there has other ideas, questions, comments, throw them in at any time, and we'll take it wherever it happens to go. Redundancy is one of the big things that I always beat the drum on, because anytime you have a path, that path is going to go down, whether it's rain fade on a C-band satellite, whether is that C-band or KU band? One of you guys, Jeremy, can you answer that for me?
Yes, we have both actually, and IP at some sites too.
Which one is the one that's most susceptible to rain fade?
KU, generally. The wave is about the same size as a typical raindrop, so you have a lot more interference from rain.
Now, see, I never thought about it as raindrop being a wavelength. That's kind of cool. So we'll talk about that a little bit. We'll talk about how to monitor, because a lot of us too are dealing with traditional wired remote controls. You know, your Gentner, your Sign Systems, Burke. I'm not going to try and name them all. Those are the ones I can think of. But some of those you're limited by the number of channels. So in those cases, how do you decide what it is that you're going to monitor? You know, things like that. If you're doing SNMP, you might be able to monitor everything. And how do we scale it? How do we grow it? Josh, for example, if you add a couple of translators, how do you do that?
A couple, like co-located or separately?
Either or.
Co-located you can typically do with a traditional remote control without too much of a problem. Separately, we would do that with some type of an IP-based remote control, most likely. We don't do a lot with dial-up anymore. It's available in most of the major remote controls, but we don't do much with it. But typically some type of an IP deployment. And again, if you're using a VS for a translator, in that case, you can do it with SNMP if you have an SNMP capable device, or if you're only monitoring the stuff, if everything is in the transmitter, say you're using the streaming decoder in the transmitter as your STL, then you can do it all from the AUI. It's that's the nice thing about the Nautel stuff, is the transmitter can be your remote control in a lot of cases.
Oops, very good. I just trying to clean up my microphone a little bit, and I got more things going on than I got brains to deal with it.
Uh-oh.
Let's see if that cleared it up a little bit. Sometimes this thing likes to turn on multiple microphones for me.
Oh, you sounded fine.
There you go. All right. So back to the presentation. So here we go, talking about redundancy. This is your one and only sales plug here, Josh. So Max Connect Wireless is the answer. What was the question?
What do you do when you can't get IP to your site, basically? This is what we would do. I didn't know if you wanted me to talk about it, so I didn't say anything. If there were multiple sites to deal with, we would deploy Max Connect to each of those sites as an LTE based IP connection, and it's prioritized LTE. You get a public static IP address, which allows you to access the devices at your site without having to worry about fighting with a VPN or a NAT or anything like that, because typical consumer-based LTE connections are double-blind firewalled, so you can't get through those. This gives you the flexibility of, say, fiber or an enterprise-grade copper connection without having to worry about that. It's all wireless. It's less likely to get blown up by lightning. But it's a huge asset anytime you're talking about site control, because it lets you do full port forwarding. It has a firewall built in. The data consumption just for control is minuscule, so you can do it with a relatively small plan. And if you want to use it as a backup STL, you can scale it based on what your estimated data consumption is. So it's a great option for a backup STL or just remote site access. Max Phone, like I said, we don't do much with dial-up, but I know a lot of folks still do. We offer Max Phone that goes along with it that will actually give you a VoIP-based connection that does work with the remote controls, which is really slick and helpful in today's world. And we've even made it work with sign systems. So sign systems doesn't even like to work with a POTS line. So
yeah, well, and I remember there were a lot of times early on when you tried to dial up into sign systems with a cell phone, and they didn't play well at all with the codes.
Oh, no. Well, and a lot of that was based on a tone shift in the line, especially, and even a lot of the like I know Comcast and Spectrum's VoIP algorithms that they use in their built-in modems, they still do tone shift. And the sign systems, the DTMF isn't real DTMF. It was recorded in from a function generator. So if you don't hit that exactly right, and it goes out, if there's any tone shift at all, it just won't recognize the tone, and it'll say, oh, I don't know what you are, and you don't know your station's off the air.
Right. Now, the cool thing about this is because you're 3G, you can provide either modem or VoIP, so you can handle both traditional dial-up and IP-related remote, correct?
Yeah, they're in separate boxes. It's not all in one. And it's actually 4G. 3G is old and slow. 4G is current, and 5G is mind control. So
I'm debating myself.
But yeah, we can offer both, and we have quite a few customers that have both, and they work relatively well. We've got people using the Max Phone with every type of remote control. We actually had one customer that got it for a remote site during the COVID thing because they didn't want their person to have to use their cell phone. And they ended up getting one of ours, and they were using that for incoming calls for their marketing department. So,
gotcha. Now, Jeremy, switching over to you guys. You guys have a lot of transmitter sites. How many all told?
We crossed over 1,000 this year between all of our formats. We're, I think, 1,005 or 1,006 as of today.
And with that many sites, I mean, you guys have a NOC, a network operations center, where you've got several people whose only real job is to look for things going wrong, correct?
Pretty much, yeah. It's staffed 24/7, 365. Exactly. We definitely subscribe to that. We monitor all things. I actually wanted to have a photo, but we actually are kind of still in the process of remodeling it. So we've added staff and workstations. It started years ago as just a 2-desk little area.
Right.
It's moved into having, like I said, full-time staff, 24/7. I think we have 10 or 11 folks in the NOC, and we needed a bigger room. So we started that in February, and then, the world paused. So it's not quite done. I didn't want to send a picture of a room full of desks with a few monitors on the wall. But exactly, we monitor everything through our NOC, and what that does is it prevents the engineers, who each one of our field engineers is responsible for 30 plus signals. You don't want to be getting phone calls from remote controls all the time for that. So that's what the NOC's main purpose is.
So they basically triage, and if there's something simple that doesn't require engineering presence, then you can sort of triage it and save the local guy from getting woken up.
Yeah, years ago we decided, this is quite a long time ago. The NOC, I think, in our organization was born in about 05. I should actually have that date, but so let's just round to 15 years to be safe. And it has changed a lot. And years and years ago, the guy who was primarily responsible for getting this launched, Alan Guthrie, many people have heard him and worked with him. He passed away a few years ago, sadly. He was the one who had this vision of what we could do with remote control. So, as you mentioned and Josh mentioned, the tones through POTS lines. We had POTS lines at all of our sites if we were lucky, or we used the Tellular, I think what it was, the old Tellular modems.
Oh yes.
So yeah, it was real fun. We ended up going to, go ahead.
I'm going to say, when you think about it, back then too, you're working with like a sign systems IP8 or whatever, so you're limited by the number of channels in the remote unit, exactly how many things you can monitor.
Yeah, we walked the floor at NAB probably 10 years ago looking for something that would do a lot more than what we could do, with just physical analog inputs. And SNMP was the answer for us. It answered all the questions. So as we moved away from POTS lines to a VSAT system, so we do all of our, well, not all, 98% of our sites have all of their telemetry that's delivered through our 2-way IP connection, which is all on the KU band satellite. We were able to get all this data from the rack. So today, every device that can be talked to is talked to, and we basically meet with manufacturers now and say, if it doesn't speak SNMP and it's in the air chain, we really can't even look at it. And we kind of take a hard stance on that because of our size and the need to not be dispatching engineers to be, trying to find out if it's just something needs to be reset. The cost involved in that is astronomical.
Well, especially more and more today with the various restrictions and things going on, it's not as easy as just jumping on a plane. I mean, you can still do it, but it's certainly, there are more challenges involved than there were this time last year even.
Absolutely.
Joe Niffen has raised a good point, and this is something that I'll address to you, Jeremy. Do you monitor your streaming services, and what equipment do you recommend for that?
That's actually a really good question. So EMF we like to say we're weird. We do things a little different than a lot of other places. And one of those things is we actually have a few, I hate to use the word silo because it's a little negative. It has some negative connotations, but we've siloed out our studio, our streaming, our RF delivery. So we have a few different teams that manage that. So our streaming team actually works completely independent of engineering. Of course, they're married in a lot of ways because we share the same audio and we share the same uplink room and things. They have a number of systems they use. One of them is our in-house applications developers have written some software to monitor our IP streams. So those are the ones that are primarily delivered to mobile devices and, you know, Amazon Alexa and things like that. We have a lot of custom software because there wasn't really a off-the-shelf package that worked for the way we do things. Again, being weird, we have a lot of streams to be able to localize them. So we actually are able to play local content. If you're listening in Dallas, you'll hear the Dallas Air One. If you're listening in Southern California, you get the K-Love local IDs and local content. So that's just not something that you can just go buy as far as we could find. So our guys wrote some stuff to manage that.
Now, do you do the same thing with your NOC, with the SNMP stuff? Are you using stock SNMP manager, or did you roll your own?
We decided probably about a decade ago, give or take, to go with the Automat Relio, which has morphed into, I guess was it the Automat Relio? It's morphed into what they call the Control now, or the Automat Control, which was for its time was really outstanding. The script design, ability to link all these different devices together to do complex ATS, and it acts as an SNMP manager or concentrator. So we can have all the devices talk right to it directly. In fact, Nautel's got so many amazing readings that you can get through SNMP. The MIB is just phenomenal. And so if we want to go crazy, we'll have the entire thing set up in the Relio to monitor every fan, every module, every temperature. And the great thing is we don't actually have to transmit that to headquarters. I know our VSAT system is very slow. It's we always joke it's like AOL dial-up, and there's, you know, it's a shared connection. So we have it's sharing your AOL with 1,000 of your closest friends, you know. So the SNMP manager or device concentrator is a phenomenal way to get all that data and then just look at it on a display page. So we use the Relio. I know we're one of the few customers in North America that uses that. And it's been difficult to replace because it actually gathers so much data, and then it only sends what you ask it to as an alarm to Broadcast Manager, which unfortunately is end of life, and we're looking at a replacement for that today. But that's the software back end that it transmits all of the alarms and captured data and things to.
Right, and you made a good point. I mean, like a fully loaded GV40, for example, is sending on the high side of 2,000 different monitoring parameters at any given time. So if you've got a busy site, you could really clog up a network.
You know, and that's actually a really interesting thing to look for when you're shopping for SNMP concentrating devices. And there are a lot of them, and you can roll your own very easily. If you have a high-speed internet connection or a cellular connection that has a little extra data, you can buy these things and they will capture all this stuff and just spit out whatever you would like. If you don't need it in a really tightly formatted way with complex APIs in the back end. But the thing to look for, and we found this to be, I would say, a roadblock, a lot of devices only capture so many OIDs. So let's say you want to you have a Nautel, you have two Nautel GV40s, main and a backup, and you've got you know, your antenna switch and your dummy load and all this stuff has SNMP, and you realize the device you bought only does 512 OIDs, and then you have to start going, oh, well, what do I actually really want to monitor here? And that's been a thing. You know, some of these devices are limited by the number of OIDs that you can actually monitor or listen for. So ask that question when you're shopping. It's really important because you might find you end up buying something that is wholly inadequate for what you actually think you're going to be able to accomplish.
Right, and that doesn't matter what size you're talking about. I mean, Passler, for example, makes a free SNMP manager, but the free version is limited to 100 samples. So that's all you can look at. Now, the cool thing about it is some equipment, and I'll pick our transmitters because that's what I know best, obviously, but we do summary alarms. So you can have like a power supply summary alarm that'll tell you if any power supply alarm is fired. So one alarm places in a big transmitter almost 100 alarms. So you can do some concentration within your equipment too. So it's always good to do a little research on what you've got available. So carrying on, I'm not exactly sure where I was going with this particular slide. Oh, there we go. I forgot to take all Josh's automations out. So this is what happens when I borrow slides, but Josh had really cool content and it was kind of nice. So you basically, you have two devices. You got your manager and your agent. And I know, Jeremy, you talked quite a bit to it. Josh, you do a lot of work with setting up like Burks for existing sites. I know you did a rewire in Shoreview recently, and we'll touch on that in a little bit. But what are the things you look for at a more, I guess, granular level for a smaller facility?
As far as SNMP or just control in general?
Control in general, but then break it into SNMP. Hit me with all of it.
Okay. Basically, whatever. I'm kind of weird too, where I want to monitor everything. We're still working on a project in Florida that is 2 TV stations. It's part of the repack. And the amount of stuff that we're monitoring, I'm about to run out of channels in the Burke that's there, because there are 2 Rode transmitters that we're monitoring for the 2 TV stations. There are pressure sensors, temperature sensors, generator control. There's 2 generators, 2 transfer switches, everything that's in there, and then monitoring the SNMP for each one of those transmitters. We're monitoring the pump stages and the cooling stages, and you can't monitor all the amplifiers in them. Otherwise, you'll use an entire Burke just to monitor one Rode transmitter. Because again, there's so many channels. And like Jeremy said, 512 OIDs, Burke has 256 channels total for monitor or for status and metering. So we have to be careful about what we're going to add. The functionality is great. It's just we're limited without adding another physical unit. The basics for a smaller station, you obviously want to monitor your forward reflected power in your transmitter, whether it's through SNMP or through a physical connection. Whatever transmitter control you want, I always recommend on pressurized lines doing some type of a digital pressure sensor, not necessarily just a low pressure switch. That was kind of the standard for a long time, was if it gets below this much, it opens the switch and tells you there's a problem. But there are so many options out there now that are available, both just on the open industrial market and from the remote control manufacturers, that can give you a sample that you, as long as you can set the offset in the remote control, it can give you a real-time tracking reading of whatever your pressure is. And that's huge, especially in a higher power installation. If that line loses pressure and you have a hot day and a cold night, bang, and your line burns out. We had a station that before we came in to do it, they actually had that happen. That I always recommend temperature sensors. People like to skimp out on those, but those are definitely a plus to have, because if you can monitor the differential on your air conditioner, you can know if your air conditioner is failing before it fails, which is kind of what you want, because I've always hated getting those calls of, hey, it's 130 degrees in the transmitter building and the transmitter's at 8% power. Well, why? If you monitored the differential and you saw the differential drop from 30 degrees to 6, oh, hey, we probably ought to do something about that. So there's a lot of that goes into it, just things that you don't think of, electrical monitoring and stuff like that. Again, these are things that don't cost that much to monitor. You can monitor 3-phase electrical service with 3 outlets wired one across each phase, and then wall warts plugged into metering channels of your remote control, and you can monitor all 3 phases. You don't have to spend $1,500 on monitors for that. There's all kinds of cheap, effective ways to monitor the things that you're looking to monitor.
Yep.
If I could piggyback that, what you said is absolutely gold, because we started realizing that even though we're a nonprofit and we don't play paid commercials, downtime is downtime for radio.
Absolutely.
And if you go off the air because of something that you could have been watching, your air conditioner or line pressure or anything, I mean, there's dozens of things that you can keep an eye out for. If you can get ahead of those and do preventative maintenance, you'll save yourself that downtime. And one way that we've always been able to kind of justify it is we say, you know, how much does it cost to dispatch a contract engineer? He's charging 75 bucks an hour. He's got to drive all the way across through, you know, half the state to get there, and to fix something that we should have been watching in the first place. So you know, especially for management, they want to see a return on investment. So you're walking in and you go, I need $5,000 to monitor all this stuff. But if we don't miss spots and I don't have to send out a contractor on Christmas Day at a premium, you know, we've paid for it already.
Well,
So
and that's the thing that we've, you know, I tell my clients all the time, and they kind of chuckle. I want you to put me out of business. And they go, what are you talking about? I'm like, I want to get your facility so reliable that the only time you see me is for a monthly maintenance check to stop in and change filters and take readings and stuff like that. I want to have everything remote controlled and monitored remotely so that we know exactly what's going on. So if there's a failure, we know exactly what to bring before we go. You know, whether it's an air conditioning failure, or if you're, you know, if there's a problem with the transmitter, you know, is it a plate fault? Is it a breaker trip? Whatever. I'm a huge proponent of cameras. There are so many options to put cameras at transmitter sites now. Wise cams, the pan tilt zoom wise cams are $30. And the nice thing about them is, even if you're using it with an LTE or a metered connection, it only streams on demand, which is great. It'll sit there and it'll, you know, if you get a motion alarm, or if you get an alarm from your remote control that something's happened and you want to log in and see exactly what's going on, you hit that. It doesn't start burning your data, whether it's on a satellite or a DSL or an LTE connection, until you actually connect. Then it lights up a stream and says, oh, okay, here you are. You can toggle back and forth between HD and SD. And that is a huge advantage if you've got a remote site, to know, okay, I see these fault lights on the front of the transmitter, so that tells me that my low voltage power supply failed. So I'm going to grab something that I can put in there before I drive 2.5 hours to deal with that. Because it saves a lot of transit time and a lot of headaches of going, I should have brought this with me. So
yeah, I've been to way too many tower sites in the old days, wishing I had known what the problem was. All we have is silence. And we have, with the size of our network and the number of engineers that we employ full time, it's really nice when a NOC can call and say, you know, we see this thing. It looks like the audio processor doesn't have any audio, and I can't talk to the satellite receiver. So very likely the satellite receiver has failed, or it's unplugged, or something like that. Where if all we knew there was just silence, you know, we might have to bring half a truck worth of stuff out there to determine that. And you know, so it's really about not only cost savings for your business or your ministry, it's about saving yourself hassle and having to make 4 trips. You know, and I think it's really nice to be able to walk into your boss's office and say, well, I was able just to reboot that remotely. We use a lot of, we've actually started using remote PDUs, so we can actually turn off certain outlets through SNMP.
Yep.
And so if we go, gosh, we can't ping that device, let's just try resetting it. And worst case, we do the Hail Mary and reboot the UPS. And we have saved thousands upon thousands upon thousands of dollars in contract engineer time to prevent, or I mean, truly what the problem is you don't want to be off the air.
Yeah.
You want to be on the air. So money is one thing, but your listeners are not going to put up with it anymore. They're going to go somewhere else. So we don't want our listeners telling us we're off. But we want to know within a few seconds to be working the issue beforehand. So every device you can touch, if it can be remotely monitored, it's nice to at least get a heartbeat from it.
Yeah. I always knew when I got a call from your NOC that one of your stations that we took care of was off the air, that they had tried everything that they could to get it back on before they called. And the fact that everything is remote controllable, I've actually adopted a lot of the standards that you guys put in place for builds that we do, such as the same UPSs and things like that, because if they're reliable enough for the KLove network, then they've been well vetted. So that's served me well. So thank you.
We've made some mistakes, trust me. So nothing's perfect.
You kind of learn by doing.
Yes.
Now, we've got a bunch of questions and comments in here, so I'm going to start whittling down through these. I've got a question about a manufacturer of digital line pressure meters, and I'll ask you guys your opinion first, but Matt Golston's put an answer down also. So So what do you like for monitorable line pressure meters?
Well, actually, EMF has not employed them. So, Josh, if you guys have used them, go for it.
There are, if you want to get one that comes with nice instructions as to how to interface it with a Burke remote control, Burke has the PT1, which is a negative 100 kpsi to positive 100 kpsi device that actually spits out a 1 to 5 volt sample. Those are, you have to do a little bit of fancy math with a virtual channel to make that work, because you've got to compensate for the offset of that volt. Otherwise, you can't calibrate it to 0 and it won't give you a true reading. You won't know whether your line lost pressure or whether your sensor died. Those are, there's two companies that make them as well. One is Panasonic, and you can just Google Panasonic line pressure monitor or gas pressure monitor. Another is Keyence, K-E-Y-E-N-C-E. Those are, and they have all kinds of different flavors of them that monitor different pressure levels. They monitor different types of gases. They're all designed for industrial settings, but they're great because they have, in addition to the sample output, they have a little screen on them. And you can also set the ones that we typically have used, the Panasonic is a DP101A, that's one, and I can't remember what the Keyence part number is that we've used. But they, in addition to an analog sample, they also have 2 digital outputs that you can set thresholds in the device to actually give you status alarms for high and low pressure, if that's how you prefer to monitor. But it has a screen on the front that actually reads the pressure out to you, so it makes it a whole lot easier to calibrate your remote control, because you know exactly what that pressure is supposed to be, and you can compensate to make sure that it tracks appropriately. It's really made things a lot better than the old days of Fartronics, which was the little plastic box, and you had to try to stick that little tiny hose on there that wasn't a standard size and hope that it didn't fall off and rot, and it was just a mess. So yeah,
I think that actually you used fish, like, you know, the bubbler hose on those, if I remember correctly, right?
That's the size it was. It was bubbler hose, which wasn't a standard, so you had to buy some kind of a reducer, and then you couldn't get a hose clamp that small, so you kind of had to cinch it down with a zip tie. So it was, yeah, those were fun.
So Matt Golston has mentioned that a great SNMP monitorable dehydrator that he likes is made by Pure Gas, now Alltech Air, that'll monitor 4 lines from one device, high volume load to keep up with small leaks, and will email you if it detects a leak.
Yes.
So there's something else. alltechair.com, cable pressurization dryers. Certainly you can email me and I'll be happy to send you the link. Matt's got it here in the questions. Thank you for that, Matt. Let's see, jump in up here. Okay, so our CEO's online. Hi, Kevin. And Jeremy, he's got a question for you. What's your average to roll a contract engineer?
Oh, time you mean, or
cost?
Cost.
Oh, I'm sure he's looking at cost. That's his deal.
Let me mute my mic.
Yeah. No, it actually varies so much. We have obviously large markets where the contract engineers are high demand. It's not uncommon to see $75 to $100 per hour, especially for emergencies. Overnight time can be even higher. The highest one I know of is in an area that we truly have no other options, and it's $250 an hour. So we have to use him sparingly. Contract engineering is an interesting thing these days. Most of the guys are very, very busy, and they have to triage and deal with whoever is probably losing the most amount of money on a given day. So I would say on average, it's probably around $50 an hour, give or take. We have guys who are just ham radio operators who live just down the street, and they know enough to tell us if a light was red or green. And then we've got guys who are consummate, amazing radio engineers who we could trust to just take care of the entire thing with never walking through the front door. So I know it's a bit of a very generic answer, but anytime we call an engineer, it's costing money. And being listener supported, that's costing us dollars that and time off. I mean, that's really the biggest thing. We don't like being dark. And it's embarrassing to us when we're off the air for 2 days because the UPS failed because the batteries were dead, and we just decided not to monitor that, you know.
Yep, no, good answer, thank you. Steve Schoen has asked, is it okay to use an LM34 to monitor outdoor temperature? And if so, how do you protect it from the elements? Josh, have you dealt with that?
Yeah, there are certain board designs. I think CircuitWorks made one that had an LM34 and a few other devices on it. Typically, when we've had to do those outside, we would try to do them in some sort of like a plastic project box or something along those lines, just to make sure that it was sealed up. You know, you have to put it in, but then you got to seal it up real tight with silicone or some kind of a sealing grommet or something like that. And don't use a black box. I had a station that did that. They rolled their own temperature sensor and stuck it outside in a black box, and 75-degree day, and it was reading 110. And, oh, it's so hot. I'm like, it's not. Change it. Typically, the other thing that we recommend is on the bottom, drill some holes. If you mount it on a wall, make sure you drill some holes in the bottom because you'll have condensation in there, and eventually it will fill it up. Not to mention the humidity of the condensation evaporating inside the box is going to corrode your components. So drill a couple of weep holes in the bottom.
Sort of a sidetrack. I walked into a site in Florida once, outside of Largo, near Orlando, and they were off the air, and we're troubleshooting, and the AC, they kept tripping the breaker. And I mean, it's like, what's going on? So walk outside. There's a NEMA box on the outside, one of our surge protectors, which are not really meant to be installed outside. I opened the door and it let about 4 inches of water out of the box.
There's your problem.
Oops.
So yeah, let's jump ahead a notch here. So you remember, anybody who's watched my sessions has heard me say document, label everything, document, document, document. There are limits. Josh, what are we looking at here?
This was a remote control install that we happily ripped out back in January. That was done by a full-time engineer about 15 years ago who had a lot of time on his hands. If you notice in the upper part of the picture, all the wires are the same color. He used all yellow for metering, all red for status, and you can't see behind it, but it was all green for control, whether it was on or off. And I looked at it, the first thing I thought was, did this guy think he was Onan? Because all their wires and their generators and transfer switches are white. So, but they were brought out to a plexiglass board and wired to barrier strips that had functions designated originally, but they changed over the years. Well, then that guy retired, and the poor lady who had to take over this site, God love her, went through and found every one of those conductors and labeled it with a P-touch flag that was like 4 inches long. Well, there were probably 600 wires on that board. So it was like wading through a beaded curtain to try to get to anything. So there were, I think, 9 connections on that board that we had to use. The rest of them got hacked off with the clients, and that was the end of it. And the board's in my basement. The kid enjoys playing with it. So
it really kind of tickled my fancy, and in a couple of slides we'll show how you solved that too. Now, back to Jeremy. Andy Lowe's asked a good question. When you guys are wiring up remotes and doing remote control, do you set them the same as much as possible for AM and FM or for all your stations? How do you do it?
Yeah, we adopted a standard. We kind of modeled it after the cellular industry. So all of our racks are built at headquarters, fully assembled and ready to go, plug and play. Obviously, when the engineer's installing it, there are some interconnects between, we don't have a GV attached to the rack when we ship it or anything like that. But what we've done in the remote control is there is a specific way to wire it for every site. So we put the voltage on one channel, amperage and forward power and all that stuff, so that essentially any engineer can walk in any other engineer site and deal with an issue. He can understand how the wiring is, the same color scheme, all of that stuff is as standard as possible. The other thing we've done is we try to eliminate as much physical wiring as we can to the remote control. So this here is a great example of, I want to monitor everything, but there's no practical way to do that. I mean, obviously a book or an Excel spreadsheet would have worked fairly well in that case, but what we do with example with the GV and NV series transmitters, we don't need a whole slew of wires to get all those readings. We grab forward power and on and off, and that's it. Everything else is SNMP. So if the internet, or I'm sorry, if the IP connection to the transmitter fails, we can still tell we're on the air, and we can still do legal command through a physical relay. Everything else is through a single Ethernet cable, and it's greatly simplifies it. So as we install new transmitters and upgrade from the old Harris and Continental models that don't have those options, we move as much to SNMP as possible, and then that way every rack again becomes more and more simple. Our tower light controllers, we worked with Slatercom and use Web 600s to capture things if we need to. So all of our tower light systems are SNMP with basically no physical GPIO connections whatsoever to the controller box. It's all SNMP. Standardization, if you have a lot of sites, especially if you have other people working at your sites, is a wonderful, wonderful way to basically make everybody an expert at all of your facilities.
And you made a good point there with the standardization, and Ray Lewis has asked the question, suggestions for documenting point-to-point wiring, and he uses a combination of Visio and Excel, and I know for me, when I was documenting the phone system in our facility, it was all Excel spreadsheet because I could make a change with a few clicks.
Yeah, it's funny, I've used WireCAD, AutoCAD to some degree, although I find it just unnecessarily complicated to do simple wiring diagrams. So Visio is a phenomenal program. It comes with Office, it does, unless you're doing something that's extremely complex, or multiple T rooms tied together for a dozen studios or something. A combination of Visio and Excel is pretty much what we use in engineering. I do a lot of the documentation for our facilities as far as the standard stuff, the standard setting. So I'll draw out the rack in Visio, or like I said, WireCADs or one of those, and then the shop has an Excel spreadsheet which has where at the beginning of the wire, the label number, how long it is, its color, its destination, the connectors on either side. So you can use 8 or 9 fields and capture, oh, this is an XLR to DB9, it's orange, it's labeled 107, and it goes between the audio processor and the Pico or whatever. So those are great, and you're right, you can move things around, you can change it. If you had to swap it out in an emergency, it's very easy to fix an Excel spreadsheet on the fly, where written documentation or even an AutoCAD or WireCAD can be cumbersome, especially if you've done the inventory. I forget what they call it. There's a way to keep track of all your wires, and sometimes that's a lot to keep track of, especially if you're doing it at 2 o'clock in the morning and trying to remember what color you used.
Yeah, our original ones, I had done it in a WordPerfect table, and then just went through and scratch them out and write the new one in and scratch it out and write and you can only do that so many dozen times before it's illegible.
Wire numbers, for me personally, and everybody has a different way of looking at it. For me personally, wire numbers are phenomenal, because we've noticed as we've changed, we have generations of racks, our 1st gen, 2nd gen. We're on our 5th generation now of standard rack. And what'll happen is over time we change the equipment, but we don't necessarily change the rack standard. So we've moved from Wegener to the ATX or Pico receivers. So unfortunately, in the older racks, the thing still says, iPump, and it doesn't go there anymore. It goes to the Pico Pro 1. So having a wire number by itself is great as long as you have the reference with you. So we actually use both in our sites so that someone who doesn't have the wiring document with them can keep track. But that number being referenced, especially if you have that master list in the rack, it's wonderful. You can just replace the number or replace the wire with one label at the same number, and you're done. You don't have to worry about all the complexities of trying to track device changes and things like that.
Excellent. All right, so moving on ahead here. Let's see. The cool thing, and this is something that a lot of people don't think about, especially us, I'll say older school people. We get talking about wires and relay racks and limitations of how many channels. And SNMP for each device, well, usually the agent's embedded in the device. And then for each agent to the manager, you're talking one Cat5 cable or Cat6. I'm dating myself again. At least I didn't say Cat3. So you can, depending on the limitations of your SNMP manager, you can stack a lot of devices in there. And I mean, Jeremy, for your knock again, you said you got just over 1,000 sites you're monitoring, right?
Yes. So our manager, it lives on AWS, and we send everything to basically our headquarters, but it's in with the Amazon Web Service being kind of looped into the VPN, it's all relatively seamless. So it captures all those things on a server. And redundancy, as you mentioned earlier, is really important. You don't want your SNMP manager to be dark, otherwise you're not getting any alarms.
Exactly. Yep. So that is just one of those cool things that makes life easier. So Josh,
Yes.
back to your TV site. We got her cleaned up a little bit.
A little bit, yeah. So this is the back of the Burke relays. We have we've adopted a lot of products from Wago to solve a lot of our interconnect problems at sites, and these are actually Wago manufactured replacements for the standard Phoenix connectors that come with the Burke equipment. Because those Phoenix connectors, if you're doing a big job, you're going to crank your wrist off with all the little screws and trying to get everything seated and whatnot. These are great because they face straight out. The little orange button that you see on there is a release, and every wire is terminated with a ferrule. You can buy a ferrule crimper and a set of ferrules on Amazon for 20 bucks. You crimp the wire into the ferrule, you shove the ferrule in, you're done. It saves, I wired that entire remote control in less than 3 hours. If we would have had to do it with Phoenix connectors, it probably would have taken 2 days. They're a huge time saver.
Do they have break like so I'm looking at this and I'm thinking of 66 blocks and Bix blocks and what were those ones ADC used to use, Chrome blocks?
No, Chrome blocks are Siemens. ADC had their own bizarre flavor of block.
It was sort of like that, but it was almost like wire wrapping, but not.
Kinda, yeah.
So does Wago make something like that too?
Wago makes no, Wago makes all kinds of terminal blocks and interconnects. One of the pictures that I sent you that you may have has the rows of terminal blocks that we actually use for interconnecting with all the stuff. This site that we built in Florida, there were 6 coax switches that had to be controlled. They didn't have the budget for switch controllers because of the way the repack worked. They didn't have them before, so they wouldn't allow them to buy them. So we designed all the switch control in the remote control. Well, we had to bring those cables back into the remote control. Rather than having all kinds of goofy stuff kludged together on the back of the remote control, we brought it into a drawer that had rows of Wago style terminal blocks in them. And then you brought the switch into one side. And then the nice thing about them is they have 2 rows in them that allow you to put jumpers in. And they have all kinds of different jumpers that can be used to parallel a row of terminals. You can skip every other one. You can skip every 2. But that allowed us to common things for, say, power rails for power distribution from the main supply we used to trigger all the switches. And then it's a straight connection to the remote control, a straight connection to the switch, and we were able to do everything else in a 2U rack drawer. Along with the power supply, we have steering relays in there that are also Wago, so they also have the same type of spring clamp connection. So other than a traditional relay that we had to put in there just as a power supply status monitor, so if the supply died, that relay closes and tells you, there were no screw terminals in there at all. We were able to wire that entire drawer in about a day and a half, and it had well over 500 connections. So that really makes a difference, and it really simplifies all the interconnects by using those. And we're happy to be able to use them. It makes it a lot easier to document because we put a number strip down the middle. So you use an Excel spreadsheet, and occasionally we'll do Visio if there's some point-to-point stuff. But usually an Excel spreadsheet lets you reference the number, and you can see exactly what's connected to both sides, where it goes, what it does, and it just makes referencing what you did 1,000% easier than it is to, okay, there's 3 wires connected to this terminal. Where does this one go? And the old, pull and tug type of trying to figure out where things went.
You say the old, I mean, and there may or may not be some of us who still use that method on a fairly regular basis.
Hey, my translator still looks like that. We haven't had a chance to rebuild it yet. So
yeah, what do they say? The plumber's pipes always get soldered last.
That's right.
And Matt Golston's added another outdoors temperature sensor on the cheap, energycontrol.com. I'm not going to, the whole link's a bunch of characters, but if anybody wants an outdoor temp sensor, Matt's provided me a link. I'm happy to pass it along. Now, one other thing, this is a question that a lot of people have asked over the years, is like, we're talking about SNMP being able to monitor literally thousands of things. And how do you tell one thing from another? And the short answer is the OID, the object identifier. Every SNMP enabled device has what's called a MIB, a management information base, just a database of everything it's monitoring. And if you look at the OID, the first 4 characters just generally relate to DND and internet-based. The 5-digit character you see, 28142, for example, is Nautel. 1 is our broadcast division, 300 is a VS300. So I can tell you by looking at the OID, assuming I have the MIB file, exactly what function is being monitored just by that series of numbers. The cool thing about that is that every single function for every single piece of equipment will have its own specific OID. So that OID, if you're looking at an SNMP manager, you know exactly what you're looking at. And that was just a cool little side note, because I know for me, SNMP was one of the harder things to wrap my head around. And then once I caught on to it, it's like, whoa, the light came on. And the only thing that made more sense to me was when I figured out current flow through a transistor junction 40 years ago. And same deal. It's like struggled with it. And I was like, oh. So,
yeah, Jeff, it's kind of funny you say that, because I was the same way. It seemed a little overwhelming at first, downloading a free MIB browser off the internet and looking at this stuff, and you're like, what am I supposed to do with all these numbers? But when you start looking at the manager side, a lot of them, the good ones, actually you don't have to type that number in. They allow you to pair it by the name, and they'll say, here's the device, and you can browse out. So don't be frightened by the OID. It's super long and complicated, but you don't normally have to memorize that.
Right. No, you certainly don't. The cool thing is that most manufacturers, and I've shown the link here for ours specifically, but most of us will provide the MIB files, so you can go to the folder that the MIBs are in and download the one specific to your transmitter. If you wanted to open it and scroll through it, it's a text file. You could do it. Not sure what. Well, if you've got the little OID structure chart nearby to tell you how it's built, then you can sort of tell exactly what you are looking at.
There was one thing I wanted to mention on that real quick. Sorry.
Yeah.
That we've run into, since we do a lot of SNMP, and I found it to be relatively common in prosumer or consumer grade equipment with SNMP, is they will provide a MIB that has the most glorious, information ever, and none of it actually goes anywhere. We have a certain UPS that we've started deploying to our translator sites as we've been upgrading the monitoring there. And we looked at the MIB and we were just blown away. And unfortunately, none of those actually are connected to anything. You have to buy the super duper high end ones to get that. So they might use a common MIB for something, but if you buy the $150 device off Amazon, you're not going to get all those features. So test it and do reads and writes to those OIDs before spending all day in the remote control configuring scripts when it might actually provide that data.
Right. Yeah, it's very much your mileage may vary from one piece of equipment to another, or one manufacturer to another. I mean, I know we write our MIBs specific for each model that we build, so that's a little less frightening, but still, I mean, folks make mistakes even. The cool thing is that there are, and this is an example from SolarWinds, has a free SNMP manager. And of course, like everything else, free is very basic. As you want to add features or graphing capabilities, you do add costs, but most Passler, PRTG, SolarWinds, their iReasoning has a nice little MIB browser that's free, so you can go in and see what's available for that. Most of them have some level of support or information. It can be a lot to wrap your head around. And yeah, Jeremy, like you said, it's kind of intimidating when you first look at it, especially if you're an old school analog volts and current sort of guy, and this ones and zeros stuff is kind of scary.
It can be, but the beauty of it is once you get over that hump, just like we all had to get over humps of our first tube change, or trying to find that bridge rectifier that went out. Once you get over that hump, you realize that it is extremely powerful. Some of the new modulation monitors from like Inovonics, you can actually get all of that data in real time sent to SNMP and build amazing looking remote control pages that have your remote control, your analog modulation monitor built into your remote control. So the possibilities are truly endless, and you don't have to have a bunch of physical wires all over the place. Just stick it into a network switch.
Right. Now, and the cool thing again with it set up like that, and depending on how you segregate it or lay it out, you could theoretically have a whole bunch of people monitoring. You could have one person monitoring this cluster, one person monitors sort of. I know when I put this up yesterday, you said, "Oh, this is what we'd like our NOC to look like." I also noticed that Sam signed in. So, Mr. Wallington, if you're listening, you're on notice now. This is what you're aiming for. Anyway, let's see, where did we go next? I think that was the bulk of what we had. I've been sort of answering the questions as we go. We got the point-to-point wiring. So if anybody does have any questions or wants to throw a comment in, throw your hand up. We're sitting right at 1:58 by my clock. I will throw you up a few online sources. As I said, we do archive all of these webinars, so you'll be able to get to them either through the webinar link on our main page or through our YouTube channel. We do put out the Waves newsletter every 3 to 4 months, give or take. I think Fiona's going to be chasing me for something for that shortly, probably. So by all means, feel free. That's subscription-based. And on behalf of Jeremy and Josh, well, first, on behalf of us, Jeremy and Josh, I want to thank both of you very much for spending so much time with us today.
Absolutely.
It was a blessing. Thank you for the invite.
Yeah, it's been great.
Been a whole lot of fun, and I have to confess that I may or may not have learned a lot. Actually, I definitely learn a lot every time I talk to both of you. So, folks, once again, thank you very much. Be safe out there, and we look forward to seeing you next time. Thank you. Have a good day.
Thank you, Jeff. Take care.
Thanks.